The last video presented experimental evidence that the Sun, the Earth, and meteorites are made mostly of the same elements, although the top of the Sun's atmosphere is covered with the two lightest elements, hydrogen and helium, element number 1 and element number 2. The first video in this series presented experimental evidence that the Sun itself exploded and gave birth to the solar system. Thus, every atom in this scene, including atoms in you and me, came from the Sun when it exploded 5 billion years ago. I would like to start today's video on neutron repulsion by asking Professor Manuel to tell us the key message, the central fact that we should get from today's video.
Thanks, Andrew. The key message is this, that to understand the largest objects in the cosmos, we have to first understand the very smallest objects, because that's where the energy is stored, and that energy is stored there because rest mass is stored against the repulsive forces between neutrons.
In this third video, I will first let Professor Manuel explain the source of energy that causes the Sun to shine. I will then ask him to comment on the tremendous change in character of nuclear particles that were ejected from the Sun to become atoms of you and me and the material shown in this beautiful fall scene. First, Professor Manuel, can you tell us how the Sun can shine if it is the iron-rich remains of a supernova?
Thanks, Andrew. That question plagued us for 25 years, from 1975 until 2000. We knew the Sun couldn't shine if it was mostly iron. We had absolutely no doubt that the Sun was mostly iron and the Sun was shining. If you'll show the slides, we'll offer an explanation for each one as we go along.
In 2000, 5 students in an advanced graduate course in nuclear chemistry made 3D plots like this of nuclear rest mass data for all of the 3,000 kinds of atoms that comprise the entire universe, and found out why the Sun shines. In the figures, the vertical scale is energy. The horizontal scale is total number of neutrons and protons. The depth scale is the fraction of nucleons that are protons. You discovered neutron repulsion?
Thanks, Andrew. No, we didn't discover neutron repulsion. What we did was we recognized neutron repulsion was the nuclear force that powered nuclear fission that Otto Hahn discovered in 1938. He received the Nobel Prize for that discovery in 1944. The very next year, in August of 1945, neutron repulsion was the source of nuclear energy that powered the atomic bomb that exploded over Hiroshima, Japan. That will be shown in the next video.
How do you know that neutron repulsion caused the bomb to explode?
Well, Andrew, adding a single neutron to the uranium nucleus is what triggered the explosion that produced the fission event.
To reveal neutron repulsion, Professor Manuel and his students fit past parabolas to the data points at each mass number, as shown here, and extrapolate the data to the front panel, where Z over A equals 0, to show powerful neutron repulsion in every nucleus with 2 or more neutrons. Ordinary nuclei in the lower center part of the graph are stable because of attractive forces between neutrons and protons. Nuclei made of neutrons only would lie on the front panel at Z over A equals 0 and be energized from neutron repulsion. Nuclei made of protons only would lie on the back panel at Z over A equals 1 and be energized from proton repulsion. Blue dots in the next figure illustrate the excess energy that clusters of neutrons of all sizes have from neutron repulsion. Blue dots on the front panel at Z/A=0 represent nuclei made of neutrons only. Neutron repulsion gives approximately 10 to 22 MeV more energy than that of a free neutron. Red dots on the back panel at Z/A=1 are made of protons only. They have even more energy from proton-proton repulsion, plus Coulomb repulsion between positive charges. That's all fine and good, Professor Manuel, but could you please show the nuclear reactions that make solar luminosity, solar neutrinos, and solar hydrogen pouring from the iron sun?
Thanks, Andrew. Yes, I'll do that, and also explain the difference between ordinary nuclei and nuclei when they're compressed in the core of the sun.
The 2D figure in the upper left corner shows ordinary nuclei made of neutrons and protons along the bottom. Gravitationally compressed neutrons have more energy and lie along the line at m/A is approximately 1.02. Gravitationally compressed protons represented by the red dots would have even higher energy and spontaneously decay to neutron clusters. On the right side of the figure, we see that a neutron emitted from the core of the sun will release almost twice as much energy as that released by hydrogen fusion. On the lower right side of this figure is a comparison of the energy released by neutron emission, hydrogen fusion, and nuclear fission. On the lower left side of this figure are the 4 reactions triggered by neutron emission that generate solar luminosity, solar neutrinos, and solar hydrogen in the proportions that are observed. Professor Manuel, if neutron repulsion gave birth to the solar system and now sustains the very operation of the sun, is there any compelling evidence of its earlier role in the cosmos?
Thanks, Andrew. Yes, there are many indications that the entire cosmos is fragmenting. Only a few days ago, NASA astrophysicists released images which show that the very core of the Milky Way itself is fragmenting.
Wow! The link shown there will take you to this image that NASA released on November 9, 2010. Finally, Professor Manuel, you promised to comment on the tremendous change in character of nuclear particles that were ejected from the sun to become atoms of you and me and the material shown in this beautiful fall scene.
Thanks, Andrew. Yes, the character of the Hindu goddess, the Hindu sun goddess, Kali, illustrates very well the character of neutrons when they're confined in highly compressed regions of heavy nuclei and the cores of stars and galaxies.
Nuclear particles, with the violent, angry, and resentful personality of the sun goddess Kali, holding a severed head in one hand, wearing a necklace of human skulls, and standing on the chest of her slain lover, Lord Shiva, were ejected from the sun to become the material shown in the last scene. Thank you for taking the time to view this video. Questions and comments would be appreciated. Links and references to scientific papers concerning the subject can be found in the video description.